Hello everyone and welcome to our channel Maths Teasers. In this video, we will learn about Sabine's formula. The main purpose for making this video is to demonstrate how PDPU lecture halls are efficient in terms of reverberation to provide ideal teaching learning environment. In the construction of any classroom, the materials used such as wood, paint, steel, etc. have different sound absorption coefficients.
To get the practical experience and to check the reverberation time in a classroom, some of the PDPU students did this experiment by calculating major objects' absorption coefficient and calculated the reverberation time of a lecture hall practically by measuring each and every basic surfaces we can see.
Now we will begin with some brief explanation about reverberation time and Sabine's formula. For the reverberation time, we first need to understand what reverberation is. Here's the definition of it. A sound produced in a volume is reflected multiple times from the various surfaces. As a result, sound persists in a volume for some time of gradually decreasing intensity even the source stops emitting the sound. This persistence of the sound in a room due to multiple reflections even when the source stops is known as reverberation. In big halls or auditoriums, to reduce reverberation, the roofs and walls are covered by sound-absorbing materials like compressed fiberboards, rough plaster, or draperies. After understanding reverberation, we will go in the brief explanation of reverberation time. Reverberation time. Time taken by a sound in a room to fall from its average intensity to inaudibility is called the reverberation time. Next, in this video, we will have overview of the Sabine's formula. On the basis of this concept, Sabine came up with a formula for determining the quality of a sound in a lecture hall, auditorium, concert hall, or any other venue where people spoke or played music. In designing a venue, as just described, engineers and architects need to determine the sound reverberation time. Number 1. Chairs. Number 2. Strips. Number 3. Side walls. Number 4. Ceiling. And number 5. Glass full. Number 6. Ceramic. Floor. Number 7. Window. And last, volume of the hole. Number 1. Chairs. The number of chairs are 75. The absorption coefficient is 0.08. Number of chairs are 75, hence the area is 42 into 42 minus 2 into 7, the whole into 10 raised to minus 4 meter square. Hence, the area of chairs included are 0.1288 meter square. Hence, total N into A1 into S1, that is 75 into 0.08 into 0.1288, that is equal to 0.7728. 2. Strips. The front strips are 174. Absorption coefficient is 0.08 and the area is 3.6 into 10 raised to minus 2 into 4, that is 0.144 meter square. The back strip consists of absorption coefficient 0.08 and its area 3.6 into 10 raised to minus 2 into 2.5, that is 0.09 meter square. Hence, the total is 174 into 0.08 into summation of 0.144 plus 0.09, that is 3.257. Next, ceiling. Its absorption coefficient is A3 is equals to 0.68. Its surface area is 0.6 into 0.6, that is 0.36 meter square. The number of ceiling that is to be included is 247. Now the total would be 0.68 into 0.36 into 247, that is 60.4656. Glass wool. Glass wool consists of front and back, hence 174 plus 174. Its absorption coefficient is 1. The surface area of the front side includes 0.5 into 10 raised to minus 2 into 4 is equals to 0.02 meter square, and the back side consists of S4 double dash is equals to 0.5 into 10 raised to minus 2 into 2.5, that is 0.112 meter square. Would be 174 into 0.02 plus 0.0125, and hence the total would be 5.655. Now, side walls. Its absorption coefficient is 0.45. The surface area consists of 10.55 into 3.7 into 2. Total would be 78.07. Hence, upon multiplying this absorption coefficient and surface area, the total would be 35.1315. Floors. Its absorption coefficient is 0.09. The surface area consists of 12.15 into 10.55, that is 128.1825 meter square. The back side consists of 8 into 10 raised to minus 5 into 1.5 into 5 steps that are to be included. Hence, the total would be 0.6 meter square. Upon the calculation, 0.09 into summation of 128.1825 plus 0.6 is equals to 11.59. Now finally, volume of the classroom. V1 plus V2, that is 12.15 into 10.55 into 2.925 plus half into 12.55 into 10.55, gets the answer 477.5 meter cube. Now calculating the reverberation time, V into 0.161 upon summation of absorption coefficient and surface area, that is A1S1 plus A2S2 plus A2S3 plus up to AN SN, that is 477.5 into 0.161 divided by summation of 0.7728 plus 3.257 plus 60.40 plus 5.655 plus 35.67. Hence, the final reverberation time that we calculated upon the calculations mentioned earlier is 78.7875 by 116.8719. That is, finally the reverberation time we get is T is equals to 0.6577.